One, Michael Unger here from the HR MacMillan Space Center here in our ground station theater, which is located on the unceded territory of the Musqueam, Squamish, and the Tsleil-Waututh. Today is June the 30th, and we are joined by our astronomer, Marley, to celebrate Asteroid Day. Hey, Marley, how's it going?
Good. It's good. A little too hot, but good.
Well, it wasn't the heat is by the sun, and we're not going to be focusing so much on the sun so much, but we're going to be talking about some heat that has impacted our planet and has basically impacted our planet since the beginning of time, really. And so, if you're out there wondering why are we celebrating Asteroid Day, that seems like such a destructive thing to celebrate. It's kind of less of a celebration and more a day of awareness, right, Marley?
Yeah, it's more of a day to observe rather than celebrate.
And but what exactly are we observing? Because when you say observe, are we looking up? There's not a specific asteroid that's imminently coming our way, right?
No, and that's the whole point. So Asteroid Day, you're supposed to take a moment and realize that, oh, we're a bit more fragile than we think. And more of an educational day of learning about asteroids and what we can do to protect ourselves from a potential impactor.
Yeah, and I think this is a good reminder. A day like this, as with many other things that affect humans, asteroids could have a very, very big impact on humans. Just like, say, oh, I don't know, a pandemic that all of a sudden, comes our way. The more we prepare, the more that we can perhaps lessen some of the suffering that could potentially happen on humans, right?
Yeah, exactly. And it's not like a movie or anything like that. Though some great movies have come out of asteroid impacts. I'm not going to knock them because they're good. Movies are fun,
Okay.
but they're a real hazard, and it's something that we should pay attention to and always keep like kind of in the back of our minds that this could happen at any time.
So which movies would you be referring to? Would you be referring to, say, oh, I don't know, a movie called Armageddon, where they send some miners to blow up an asteroid? Would those be the kinds of movies you're talking about, Marley?
Yeah, that one, great movie. Not super accurate, but great movie. Deep Impact is also a really great asteroid, a little more accurate.
And Deep Impact has a comet instead of an asteroid, so a slightly different, and of course, is on theme because when we say asteroids and comets, they are two different things, but potentially could have the same catastrophic effect.
Yeah, definitely. A lot of it depends on size and how fast that thing's moving.
All right. Well, if everyone out there in YouTube land, if you have any questions about asteroids, put them into the chat. If you're out there watching on Telesoptic, come on in. Today is a special time because of Asteroid Day and because tomorrow is a holiday, but we're usually every Thursday at 2 p.m. Well, let's get started with our presentation, Marley, all about asteroids. And of course, if you have any questions along the way, we will address those.
Yeah. So, like you said, there is a difference between comets and asteroids. So, comets are those icy, dusty blocks of, rock in the middle of the solar system and whizzing around. But asteroids are more rocky and made out of more metals and things like that. Both of them, if chunks of those break off, they become meteoroids. And once they enter our atmosphere, we call them meteors. So, those are the shooting stars that you see. Exceptionally bright ones are called fireballs. And if both of those things make it to the ground, we'll call it a meteorite. But all of them mean slightly different things, but are all semi related. Asteroid Day deals with asteroids, but also deals with more so impactors on a broader scale. So, Asteroid Day started in 2014. And at the time, there are approximately 1 million near Earth asteroids with approximately a 70-meter diameter. But out of all of those, only that represented about 1% discovered at the time. So they started with this 100 times declaration, which was to increase the rate of near Earth asteroid discovery to 100, like 100 by a factor of 110 years. So that would bring it to discovering 100,000 near Earth asteroids per year. And so far, there's 205 signatories. And one of the signatories and co founder of Asteroid Day is, astrophysics icon and rock star and also hair icon Brian May, which is why he's featured here. I want his hair very bad. Anyways.
I mean,
Um,
you're almost there. I mean, it
I
just needs to
know
like
if I ever got okay with my hair being long, I would keep it like that. Brian May, drop your hair tips, but that's neither here nor there. So it was started after the it's celebrated on June 30th because of the Siberia Tunguska event, which was this huge event in 1908, June 30th, 1908. So at this time, this huge rock, basically space rock, came and flattened all these trees in this area in Siberia. But we actually didn't know any science behind it until about 1927. There was a failed attempt in 1921, but the weather stopped that expedition. So as well, testimonials from the locals were really hard to get because they believe that the blast that happened was a visit from a god who cursed the area by flattening the trees and killing off the animals. So there was just over 200 square kilometers of forest that had been destroyed. So the trees were felled, like in these photos here, and they were pointing away from the epicenter of the blast. But what was interesting was that at ground zero, the trees were upright, but with no limbs and no bark. So this was a very interesting type of thing. Usually you think of an asteroid impact, you think of a huge crater left behind, but in this case, there wasn't one. There was just this large area with trees fallen over, and in the very middle, trees with no limbs and no bark. The
So
no
that's
limbs and no bark phenomenon is called debranching, and it actually requires a massive shock wave that breaks off all of the branches before that energy can be transferred to the stem of the tree. The one time that this has also been seen was in Hiroshima, Japan, after the dropping of the atomic bomb. So once that happened, scientists were able to make the connection between how that occurred in this event in 1908.
Yeah, so that's really interesting because I think like a lot of us can visualize a crater on the moon, some craters that we have on the Earth, as being like a rock actually hitting the Earth and, making that divot. Well, what you're saying is that it came in so fast that it exploded in our atmosphere, causing that shock wave, much like the same way a bomb would.
Yeah, very, very similar. Yeah. So think less of a crater, but where that same circle would be, it would just be trees completely fallen over. So like someone just stomped on the ground and
And
broke
200
everything there.
and 200
So
square kilometers is pretty big. Like
it's
that's
pretty
a
big.
city.
It is a city. I was trying to find a Canadian city analogous to it, and I couldn't find any that were well known enough for me to know for sure. But it is about the size of a small city. Yeah, just
Yeah.
completely leveled. There was such a powerful blast that sensitive barometers actually registered the blast as far as England, like seismic barometers registered the blast as far away as England. And eventually, the agreed upon theory was that it was a large stony asteroid about 50 to 80 meters across that entered the atmosphere of Siberia and then blew up in the sky. It would have been traveling about 54,000 kilometers per hour, and it exploded about 10 to 14 kilometers above the Earth's surface. And the energy from this explosion would be equivalent to the Mount St. Helens eruption. So it was this very big, very powerful eruption. What's interesting about this is that scientists didn't come to this conclusion until somewhat recently. They've been studying this event for a very long time. It happened in 1908, first scientific expedition in 1927, and we keep coming back to it. But the one reason that we were able to see it was due to a more recent Tunguska event that essentially happened a second time, but on a smaller scale. So this is dash cam footage from Chelyabinsk, Russia. And this is the Chelyabinsk meteor, which happened on February 15th, 2013. So it was a highly documented event. You'll see it as it begins to enter on the upper left-hand side, that bright streak of light. Researchers could apply modern technology to this because it was so highly documented. Whoa, it just stopped. But yeah, they could apply modern technology to explain what was seen and what was being heard, because in this video there is no sound, but it is actually a very loud explosion. You can find videos on YouTube. It shattered windows. It sounded like a bomb going off. So the video observations, the models, and maps of the damage, they were able to reconstruct the size, motion, and speed of Chelyabinsk. So basically, they worked backward from what they had. As a result, they determined that it was most likely a stony asteroid the size of a house, going 69,000 kilometers per hour, and exploded at a height at around 30 kilometers. So there's the explosion and it breaking off as it goes.
Wow.
So using the Chelyabinsk data and models, they came to the conclusion that when looking at the asteroid population estimates, interval between these big events and Lake Tunguska are in the order of millennia, but they were also able to use what they learned from Chelyabinsk and apply it to all of the findings they had from the Tunguska event and work backwards to figure out the size of that impactor. when talking about how often asteroids hit Earth, it's actually kind of hard to know how often it happens. The clearest evidence would be craters, but with geological processes, those can be lost. So we see here we have, our Earth, and it's mostly water. So anything that may hit us, not being so big to cause a disastrous impact like the dinosaurs per se, but it may just hit the water and be lost, and we never know about it. Additionally, it may hit areas that are in like uninhabited areas. A lot of humans are kind of densely packed into certain areas, so it may not have hit anywhere we'd see. Compared to the moon, we see everything that happens on the moon on the other side. The moon is not geologically active, so there's no oceans for things to fall into, and so we're able to see the evidence of what is happening better on the moon. But on terms of other things, large impacts rare. Tiny pieces, tiny meteorites are about on the order of thousands each year, but they're quite small, like pebble size sort of thing, that make it eventually to the ground. They're unpredictable, they go unnoticed, but the best places to find them would be the Sahara Desert or glaciers in Antarctica. It's easier to find meteorites on the ground and easier to date them in these places because the weather is fairly consistent in these areas, and as well as being largely undisturbed by both people and animals. Another thing we need to consider is understanding where the chunks of rock come from. So most asteroids in our solar system are in the main asteroid belt, and there's about between 1.1 and 1.9 million asteroids that are a kilometer and larger in diameter, and millions more smaller ones. 90 to 95% of these meteors will burn up in the atmosphere, which causes the shooting stars that we see. If they do make it to the ground, the meteorites will weigh less than a pound or half a kilogram. A 1 pound meteorite moving 322 kilometers an hour can crash through a roof or smash a car windshield. So they still should be considered with a great degree of caution. What you really want to worry about, though, is the shock wave when it breaks up in the atmosphere. So that's what this picture is here from NASA. It's a picture of one of their jet planes breaking the sound barrier and the shockwave that results from it. That same thing happens when something enters our atmosphere, and something large enough, a larger shockwave, is something we need to be more concerned about.
And wasn't most of the injuries from Chile Banks were people that were standing too close to large windows from that shockwave as they broke apart?
Yeah, so to my knowledge, there were no fatalities, but all of the some 1,500 or so injuries were all people who had been hit by debris. So broken glass, broken window panes, things like that, that came from the shockwave.
So the lesson is, if you see a large meteor streaking across the sky, you can go look at it, but just go outside and get away from windows.
Go outside, get away from windows, and probably cover your ears because it'll be loud in a second. Yeah. So all that said, being worried about the shockwave, we do have some really cool craters on Earth that are fun to look at. But there's a somewhat general consensus on the world's largest craters, which would be the largest asteroid impacts. It's hard to know exactly how big these craters are because they're quite old and the Earth's surface has changed a lot over time. And so that will change the crater as it goes on. But here are some of the three. So on the bottom left, we have the Manikugan Reservoir, which is a reservoir area in Quebec, also known as Lake Manikogan or the Eye of Quebec. Its diameter is 85 to 100 kilometers. It's about 215 million years old. So it happened a very, very long time ago. The one at the top is called Meteor Crater in Siberia. It's about 35.7 million years old, and it's about 90 to 100 kilometers in diameter. So still very, very big. And the last one in the bottom right is the Sudbury Basin in Ontario. They estimate it happened 1.8 billion years ago, and its diameter ranges, but a good estimate middle value is about 130 kilometers across. And as you can see, all of these don't look like the craters we normally see. The one at the top is a computer generated image because so much of the land has changed, but you can see they don't look like craters that we see in the movies. Things have changed. The Eye of Quebec has a reservoir that goes around with kind of an island in the middle. So they actually have to look at topography maps and scan the ground in radar to actually see subtle changes in the ground.
Yeah, the Sudbury one is always surprising to me because in these other craters that we see, we can sort of see how water and other like landforms are kind of formed around it. But Sudbury, like it's very hard to see, and they even like built a city around it. but you can sort of make out, sort of like the area where the impact would have landed.
Yeah, it's like a bit of an oval shape with the lake
Yeah.
being in like the top right hand corner, and then the city, I think of, or city of Sudbury being kind of at the lower southern end of it. And it's more of an oval shape than anything else, but they think that may have to do with collapsing and the recrumbling of the crater walls over time.
Right.
Of course, there is, I know you told me how to pronounce this before, Chicxulub crater, that
Chicxulub.
Chicxulub, thank you, that we can't actually see very well. And so this is a image, computer generated image with the topography being greatly exaggerated to highlight part of the trough that would have happened. So you can kind of see an oval shape. It's been annotated onto C, but this one is in the large range, 150 kilometers across in diameter. And of course, this happened 65 million years ago when it caused the wipeout of the dinosaurs. And pretty sad time, but it's big, but it's not the biggest one, they don't think. In fact, they think the biggest one is the Redirection Dome, which is about 2 billion years old, and it ranges from 160 to 190 kilometers in diameter. So this is in Free State, South Africa, and it's southwest of what is now known as Johannesburg. And the impact or whatever hit made a 40-kilometer deep and 100-kilometer wide dent in the ground. And as time went on, the crater widened and then shallowed out as rocks moved and the walls collapsed. And so it's actually hard to know just how big it was. And we can only see these kind of shallow ridges from where it once was, and very subtle topographical changes. But it's still one of the largest ones. So looking out for something that can cause this much damage is kind of what Asteroid Day is all about. So knowing that this could happen, it's happened to Earth a few times, one time wiping out everything on it, and or almost everything on it. And so keeping an eye out is what Asteroid Day really tries to emphasize, as well as educating the public about what asteroids are and the damage they can do and how we look out for them. So one of the ways we look out for them, or two of the ways, is by using Sentry and Scout out of the Center of Near-Earth Studies. So Sentry is a long-term system that looks not just at near-Earth asteroids, but largely near-Earth objects, and analyzes the full range of the possible orbits those objects could have. And it tracks those orbits for 100 years into the future, runs simulations into 100 years. It calculates the probability of the impact, and most often the object is removed from the list after it runs its simulations. Scout is a short-term system which looks at unconfirmed impossible near-Earth objects. So it monitors the trajectories, and if it's confirmed as a near-Earth object, all of the data gets sent to Sentry for further analysis. The designations are user-assigned, and it's largely more unofficial than Sentry. The reason we want to look at the ones that are 1 kilometer about it or larger in distance is because this is what they can do. So this is the Meteor Crater, or the Barrington Crater, and this happened about 50,000 years ago. And the impactor that hit it was only about 46 meters wide. So this is a crater for something that was 46 meters wide. For reference, at the top, that is the parking lot of the museum, and that is the crater. The crater itself is just over 1 kilometer in diameter. So that's not even a full meter impactor hitting yet. And that's the result that we got.
And that also just happens to be the place where Thor's hammer landed as well, right?
Yeah, very famous. Great shot. As of the count, there are 1,091,831 currently known asteroids. And of these, about 10,000 are known as near-Earth asteroids. So 861 have a diameter over 1 kilometer, and 1,409 are classified as potentially hazardous. So to protect ourselves, aside from monitoring them with Sentry and Scout, there's actually a mission underway to test a type of method we could use to protect ourselves. And it's not sending Bruce Willis to space with a nuke. It's actually called DART. So this is the double asteroid redirection test. And this mission is led by the Applied Physics Laboratory at Johns Hopkins and is managed under NASA's Solar System Exploration Program. So DART is heading to the Didymos system, which is a binary system of an asteroid and its moonlet asteroid. So it has a smaller one that orbits it, which is called Dimorphos. So 1/6 of known near-Earth asteroids are actually binary or multi-body systems. This system in particular is ideal for testing because it isn't headed for Earth. It's close enough for us to get to it. And Dimorphos is approximately 160 meters in diameter, which is the size most asteroids that get close to us are. They average out to be about that size. What it will be testing is what's called kinetic impactor technology. So it is going to literally crash into Dimorphos and see if the impact is enough to knock it into a new orbit around its parent asteroid. So this method of asteroid deflection has been thought of as an option for a long time to avoid asteroid collision, very simply just sending something, hitting it, and kind of knocking it onto a new trajectory away from Earth. So this isn't going to do much. It's more of a demonstration of capability mission. If it works, we can apply that science to larger bodies. One other thing that is up and coming is the Near Earth Object Surveyor, or NEO Surveyor. It was just recently approved to move into its next phase. So it's moving into its preliminary design phase. But what it will hopefully do is discover and characterize potentially hazardous asteroids near Earth. And it's actually designed to hopefully discover 91% of asteroids that are 140 meters or larger within a decade of its launch. So that follows with Asteroid Day's idea of trying to identify more asteroids by a factor of 100 times over. So this is part of it, kind of going to specifying a more of a certain size range. It's currently, we have found 40% of near Earth asteroids in this size range, that larger than 140 meters. And so this will help hopefully find more and maybe the rest of them. So currently, most observations are done using ground-based telescopes at night. Surveyor would be able to do it at both day and night, and it would have sensors that work in the infrared, which is really important because some asteroids that come towards us that we miss, I think like Chelyabinsk, actually come from the sun. And so we can't see them coming because the sun is in the way. So being able to look for asteroids that are coming away from the sun and from the direction of the sun is really important because we don't want to miss any. Then this isn't currently possible with ground-based telescopes. And so this launch for this really cool project is actually slated for 2026. And that's all that I have about it. There's some extra, but I know there might be questions.
Yeah,
So
absolutely. So if anyone out there wants to get on some questions for Marley on asteroids, how we protect ourselves. And Marley, you said off the top, the real importance for a day like today is, so we're out there trying to find these asteroids. We're testing out how to potentially redirect them out of the way, testing out potential things, because just like all disasters, a disaster is going to come and we might have some warning, but the more time that we have in knowing that a potential disaster may come, the more that we can prepare. And it's kind of like one of those things that as humans that we do, we tend to kind of like be more reactive to things and be less proactive about protecting ourselves for potential things that happen in the future. And that's what today is all about, looking out for these asteroids, studying them for the potential benefits they may have for us, but also making sure that they don't wipe us out, because there's not too many other places that we can just escape to. Earth seems like a pretty precious and finite resource.
There's currently 0 places we could escape to. The International Space Station would get pretty crowded if we all tried to move there. So yeah, and it's a good point that the recent mission with OSIRIS-REx going to asteroid Bennu and taking samples from there and returning them looking to see if asteroids could have held the beginnings of life to start on Earth is very interesting. Like asteroids could bring life, but they could also take it away, and as soon as they hit us. So this day is very important to just sit and remember, oh yeah, we're not as invincible as we think.
And it's also interesting because you said that there are many places that we can look for meteorites, and of course, like the small micrometeorites that we may even find in our own backyard. Do you have any tips for people that if they're wanting to go meteorite or micrometeorite hunting, that they might be able to find something?
I've heard flat roofs are good to go onto if you have a magnet, because usually the meteorites will be made with iron and things like that, which will be magnetic. So you need a magnet and a flat place to go, and you can see if you pick up anything. But if you are able to travel to the Sahara Desert or the Antarctic, that would be your best bet. That's where a lot of them are found, undisturbed. Vancouver, bit harder. You get the rain, you get the ocean, things like that.
Yeah. Yeah, so definitely, just have a giant magnet in your pocket and just say, come to the Sahara Desert, because that's something that everyone does in their spare time vacation, right?
Exactly. Yeah, I can't think of anything better.
Awesome. So we've got a few more minutes left, Marley, but we got 5 minutes left. And tomorrow, for those living in British Columbia, they may know that regulations have changed out here, and so we get to open up our planetarium tomorrow. And so it's a pretty big news here. Lots of planning and preparation for that. So if you're curious and want to get back inside to see a planetarium show, you can do that on our website and book a time. So we've got a bunch of really cool shows that we're going to be playing every day, Marley. So we've got one surfing the solar system, which is pretty basic. We'll be talking about various things in the solar system, asteroids included. But then a couple really cool movies. One called The Sun and one called Phantom of the Universe. Do you want to give us a quick spiel on each of those?
Yes, so Phantom of the Universe is very interesting. I think I've watched it twice now, and each time I pick up on something new that I kind of missed the first time. But that one focuses more on the dark matter and CERN and different particles and things like that. And the sun is about the sun. It's pretty straightforward, also really great and a lot of fun. I did enjoy them both.
Awesome. Yeah. And so your visit will include, of course, so you go to our gallery space. And for the next couple of months, we are also going to be focusing a lot on the sun as we're all feeling the effects of its heat recently. But we got a solar telescope to utilize, take advantage of this good weather. So let's get out there and look at the sun through our solar telescope. And then, of course, in August, we're going to also be looking at the skies, but there is a really fun meteor shower. They're going to be doing some events in August, the Perseid meteor shower, which happens every year, also connected to comets, as comets leave this debris and cause meteor showers.
Yeah, so the debris that we go through is from Comet 67. I think Swift Tuttle is that comet. And you're probably never going to find a meteorite from this meteor shower because the comets being made out of ice and dust are a lot more fragile as they enter the atmosphere. The ice melts, it heats up as it comes through the atmosphere, and the whole thing kind of breaks apart. So don't hold out hope for finding a meteorite from this meteor shower in August.
Right. So those little streaks of light, they're pretty much like we saw in Chile Banks, they burn up in the atmosphere, but they're not causing any large shock waves or anything like that.
No, no, they're pretty small, so they just burn up.
And where will be the best places to view a meteor shower?
So I know you don't want to use a telescope. You want to be able to see the whole sky, and so probably somewhere a bit out of the city would be the best, and just lay on your back and watch. I'm gonna try to go camping, I think, to try to see that one, but out of the city in a clear night.
Yeah, and you probably want to get as much of a view of the whole sky as possible. So not just like one patch of it, because they're mostly be coming in one direction, but really they could be coming from all directions, right?
Yeah, I think it is most of them will look like, or most of them will look like they're coming out of the constellation Perseus, hence the name Perseid meteor shower, but they can be coming from any direction, any which way.
Right. Amazing. We did have a question come in from Thet, who asks, with our thinning atmosphere due to climate change, do you know if the Earth will have enough protection from any of those meteorites and meteors in the future years?
That's a really good question and definitely something to consider with the changing in our atmosphere as well. Just the different chemical compounds that will be put into our atmosphere and may change it over time, how those may interact with things. I don't know in particular if we'll have protection from that. I do think that there are more pressing issues when it comes to the changing of the climate and the changing of the atmosphere in that regard. But with it changing, I can't say for sure. A good thing to do would actually be to look at Venus. And I know that there are a couple missions coming up that will study Venus, which we may be a proto Venus with a runaway greenhouse effect, and studying Venus's atmosphere and even looking for any geological activity on the surface of Venus. And if they find a crater or some sort of remnant of an asteroid impact, that could tell us more.
Yeah. What's always amazing, even just thinking about all of the space missions that we have coming up. Sometimes people they think about going out into space and exploring space and forget that a large part of it is helping us here on Earth and actually helping us study our planet, going to study Venus, and also going out and study these asteroids to help protect us. These space missions they're really, you could almost call them Earth missions essentially, but thinking of like looking at Earth from the outside.
Yeah, and so much of the technology that's come out of space exploration has been applied directly on Earth as well. But it's a lot. It always comes back to us a lot more than we think about. I agree.
Awesome. Well, Marley, thanks for joining us as always for this asteroid day. Thank you so much for everyone out there in YouTube land. Of course, maybe we will see you for a visit. Of course, also want to mention on Friday nights is when we're also going to be continuing with our programming with the Planetarium Theater, sticking with the Thursday, Saturdays, Sunday, Mondays in the daytime. And Asteroid Day, of course, is this anniversary, about 113 years of the Tunguska event. So I do want to shout out my aunt who just celebrated her 90th birthday. Aunt Doris lives out in Edmonton. So, hi, Aunt Doris, if you are watching. Hope to see you soon. Hope that you had a great day. Well, for me and Marley here at the H. MacMillan Space Center, take care, everyone.
Take care. Happy birthday, Doris.